All right, so we are going to go over the study guide for the Unit 1 test. I will go through all the questions and explain to you how to do them. This will be very similar to the questions that you'll see on the test, just different numbers. Obviously, make sure you reach out to me if there's anything that you still don't quite understand. So questions 1 and 2, for each of the following sequences, determine whether it is geometric or arithmetic, and then write the recursive definition of the sequence. So let's first identify what type of sequences we have. So for number 1 here, it looks like we go from 2 to 6 to 18. That looks like a geometric sequence to me because we are multiplying by 3. Okay, whereas number 2 is an arithmetic sequence because we are adding 3 each time. Okay. So now that we know that, we are going to write the recursive definition. And if you forgot the recursive definition, this is a picture of what I have written on the board in my classroom. Okay, so this right here is the recursive, and this right here is the close. So remember, the recursive has 2 parts. First part is your starting term. So in number 1, my starting term, f of 0, is going to equal 2. Okay, and then because it's a geometric sequence, we're going to use this one right here. So it's going to be f of n equals f of n minus 1 times 3. So there's your recursive for number 1. Okay. For number 2, okay, my starting term, f of 0, is going to equal, it's going to equal 3. And then it's an arithmetic sequence in which we're adding, so we're going to use this one right here. So f of n equals f of n minus 1 plus 3. And there is your recursive definition for number 2. Okay, so that is it for questions 1 and 2. Okay, questions 3 and 4. Okay. Determine whether the recursive definition represents a geometric or an arithmetic sequence. Write the closed form definition. So basically, we're going to convert it from recursive to closed. So number 3, I have f of 0 equals -4, f of n equals f of n minus 1 plus 2. That plus 2 is a giveaway that this is an arithmetic sequence. Okay. Okay, whereas in number 4, so this is my starting term, but the key is this right here. Okay, 1/3 times, key being times. So that means this, number 4, is a geometric sequence. Okay. Once we know that, we can now write the closed form from here. So for the arithmetic sequence for number 3, it's going to be f of 0 plus or minus. In this case, it's going to be plus because we're adding d times n. So f of 0 is going to be the number we put in there. That's our starting term, which in this case is -4. Okay. We already said it's going to be plus because we're going to add. And then our common difference in this case is 2 because that's what we're adding each time. So my closed form is going to be -4 plus 2n. Okay. For number 4, okay, or number 4, we're going to use this right here. So f of 0, our starting term is 243. So f of 0 times r to the power of n. In this case, r is 1/3. So my closed definition is going to be 243 times 1/3 to the power of n. And that is it for number 4. Okay. Number 5. That's a multiple selection question. Here is a growing pattern of squares. Select all the expressions that represent the number of squares in step n. So first, let's count here. So we have 1, 2, 3 is our starting. Then we go 1, 2, 3, 4, 5. So we have 5 here. And then 1, 2, 3, 4, 5, 6, 7, 7 here. Okay, so we go from 3 to 5 to 7. So that appears to make this an arithmetic sequence. Why? Because we're going up by 2s, 3 to 5 to 7. Okay, so what we're going to do is we're going to do both the recursive and we're going to do the closed. Okay, and that should match up with one of these. So let's do the recursive first. So this is an arithmetic sequence in which we're adding 2 each time. So we first start with our f of 0. So f of 0 equals 3. And then we're going to use this one. So f of n equals f of n minus 1 plus 2. Okay. Now, which one? Notice A and B are both in recursive form. So which one closely matches what I have written here? Okay. I would say B does, because I have f of 0 equals 3, and then f of n equals 2 plus f. So all they did was they switched the order, which is perfectly legal because we can add in any order. Okay, so B matches up with the recursive here. Okay, and now for our closed, okay, arithmetic sequence. So again, my f of 0 was 3. Okay, we're going to do plus because it's an increasing sequence and we're going up by 2. So my D, my common difference is 2. So it'll be 3 plus 2n for my closed. And it looks like that's going to match up with C. So the answer for number 5 is B and C. Okay, B being the recursive and C being the closed. Okay, next set of questions. For each of the following sequences, determine whether it is arithmetic, geometric, or neither. Write a recursive definition. So let's look at number 6. Number 6 looks interesting because notice it goes from term 0 to term 2 to term 6. So it's actually skipping term 1. So it might be helpful to try to figure out, based on this, what term 1 is. So let's see. To go from 16 to 9, that's going down by 7. So if I go, going from term 0 to term 2, I go down by 7. So that would mean each term I'd have to go down by 3.5, because 3.5 is half of 7. So 16 minus 3.5, that's going to be 12.5. Okay. And 16 minus 3.5 is 12.5. 12.5 minus 3.5, that's going to be 9. Okay. So in this case, in this particular case, this is an arithmetic sequence because we are going down by 3.5 each time. Okay. If I were to continue this pattern from 2 to 6, I would get the same thing. So 16 minus 3.5 is 12.5. 12.5 minus 3.5 is 9. All right. So let's write our recursive. So our f of 0 here, okay, our starting term is 16. So f of 0 equals 16. And then we're going to have f of n equals f of n minus 1 minus 3.5. Okay, so that's our recursive. Okay, so the important thing with this is to realize that there were some skipped terms here. It went from 0 to 2, so they skipped 1. So we needed to account for that when we figured out the pattern. On number 7, notice it goes from 0 to 4, and then 4 to 5. Okay, so we need to try to figure out what our missing terms are. Now, if I just look at 4 to 5, it goes from 48 to 96. Okay, so 48 to 96 is multiplying by 2. So let's see if it works out. If I multiply by 2, so term 0 is 3. If I multiplied by 2, then term 1 would be 6. Term 2 would be 12. Term 3 would be 24. Term 4 would be 48. And term 5 would be 96. So this is indeed a geometric sequence because we're multiplying by 2. Okay? So let's write our recursive. My f of 0 is going to be 3. That's my starting term. And then we're going to use this one right here. So f of n is going to equal f of n minus 1 times 2. All right, and that is our recursive. So there will be a question like this on the test where there are skipped terms. So make sure you are paying attention to that. All right. Next set of questions. Okay. A graph and table representing the same sequence are given below. Is the sequence arithmetic or geometric? Well, there's a couple of ways you can look at this. You could look here and you can see we're multiplying by 2. 1.5 times 2 is 3. 3 times 2 is 6. 6 times 2 is 12, so on and so forth. Or you could look at the graph and notice that the graph is exponential in nature. And we know that if the graph is exponential, it's geometric. If it's linear, it's arithmetic. So either way, the answer is geometric. Okay. Now, the reason I'm going to give is it's geometric because the graph is exponential. Okay. So remember, if the graph is exponential, then it's geometric. If the graph is linear, it's arithmetic. Okay. Now let's write the recursive definition of the sequence. So recursive, again, is up here. So my f of 0 is going to be equal to 1.5. And then f of n equals f of n minus 1 times 2. For term f of n, what are some values of n that make sense to use? Explain your reasoning. In other words, what values would make sense to plug in for n? Now, when I look at the table here, notice all the values are they're whole numbers, 0, 1, 2, 3, 4. They're also not negative. So I don't see any decimals in the n column. I don't see any negative numbers. And there's a reason why you don't see that. Okay, remember n is the variable that we use for term number. So if I said let n equal 1.2, that wouldn't make sense because that would mean find the term 1.2. There's no such thing as that. Likewise, if I had said find term or let n equal -5, that also wouldn't make sense because that would mean term number -5. So to answer the question, what are some values of n that make sense to use? The values of n would be non-negative, okay, and non-decimals. So non-negative and non-decimals. Another way we could think of that is non-negative and whole numbers. Okay. Non-negative whole numbers. Okay. So when they say what values of n make sense, meaning what values of n, what numbers do we use for term numbers? They're either, they start at term 0 and then we go term 1, term 2, term 3. So non-negative whole numbers, meaning we don't have negative numbers and we don't have decimals representing term numbers. So that is the answer for number 10. All right, consider the following in two sequences. I'm going to go off of here because the picture isn't quite as clear. So is sequence A geometric or arithmetic? Explain why. Okay, so if I look at the graph here, notice the graph is linear. When the graph is linear, it's arithmetic. So the answer to number 11 is arithmetic because the graph is linear. Okay. Number 12, is sequence B geometric or arithmetic? Explain why. Okay, so is this geometric or arithmetic? I would say that this right here is a geometric sequence because we are clearly multiplying by 3. Okay, so geometric because we are multiplying by 3 each time. Okay. For sequence A, describe a way to produce a new term from the previous term. Okay, so that means write the recursive. New term from the previous term means write the recursive. So what is my starting term for sequence A? My starting term looks like it's 5. So my f of 0 is going to be equal to 5. And then what are we going up by? Notice we go from 5 to 10 to 15 to 20. So it looks like we're going up by 5. So f of n is going to be equal to f of n minus 1 plus 5. Okay. For sequence B, describe a way to produce a new term from the previous term. So now we're going off of this one right here. So we said our starting term in this case is 1/9, and we're multiplying by 3. So f of 0 is going to equal 1/9, and then f of n is going to be equal to f of n minus 1 times 3. Okay. Next question, question 15. Write a closed form definition for sequence A. So we already wrote the recursive up here. Now we're going to write the closed form. Okay, so our closed form for arithmetic is going to be this. My f of 0 we already know is 5. We're going to use plus because it's an increasing sequence, and we're going up by 5. Whoops. So 5 plus 5n. Okay? And then 16, we're doing the same thing, except we are doing the closed form for sequence B. Okay? So for sequence B, that's geometric. So my f of 0, we already know is 1/9 times r, our common ratio is 3 because that's what we're multiplying by. So 1/9 times 3 to the power of n. Okay. Last question in this section. Which is greater, a of 9 or b of 9? Explain or show how you know. Okay, a of 9 or b of 9, that means, this means term 9 of sequence A, and this means term 9 of sequence B. So if I look at the sequences here, I could try to figure out which one has a higher term 9, but there's a giveaway here. And the giveaway is that sequence B, we already know is geometric. And we talked about at the beginning of this unit that geometric sequences will increase at a faster rate than arithmetic sequences. Yes, sequence A is increasing, but it's not increasing at as fast of a rate. So we don't even need to figure out what term 9s are. We know that the term 9 of sequence B is going to be greater because it's geometric. So B of 9 is greater because it is geometric and increases at a faster rate. So sequence B has the bigger term 9 because it's geometric and thus will increase at a faster rate. Okay, that is it for that group of questions. Okay. Last group of questions, and then we're done. The first two numbers of a sequence are f of 0 equals 3 and f of 1 equals 6. If f is an arithmetic sequence, write the closed form definition for this function. So if this were arithmetic, that would mean that we were increasing by 3. So it would be 3, 6, 9, so on and so forth. So for arithmetic sequence, again, we'd use this one, closed. So f of 0 is 3. We're going to do plus because it's an increasing sequence. And d is our common difference. My common difference would also have to be 3. So 3 plus 3n. Okay. Number 19, if f is a geometric sequence. So if this were a geometric sequence, that would mean that we would have to multiply by 2 because 3 times 2 is 6. So that we'll use this one. So my f of 0 once again is 3 times r. My common ratio is what we would multiply by, so that would be 2. So 3 times 2 to the power of n. Okay. And that is it that is the last group of questions for your study guide. Again, make sure you reach out to me if you have any questions.